afternoon, Dr. Grissom. This is for Lab 2 uh, for the Bluetooth devices. And to start us off again, we have to include all of our libraries, and we're going to be using two gamepads, so include the Seesaw for the gamepad, and then these identify our BLE service and characteristics. Again, the client must always be the exact same, just like, again, the lecture that we learned. And then through that, the I-squared pins use the external ports, and then address it to the gamepad. Again, all this is pretty much copied from Lab 1. And then do our BLE variables, again, copied from the lecture. Then LCD dimensions, pretty easy there. Dead zone, again, we went through all this. And then must use the exact same structure. And then this is the actual server callback. When it runs automatically, the client connects. And then, yeah, again, you don't want to draw the LCD here. And then it prints that serial here. This will clear the status area. And then the green text is to help identify it's connected. The red text means it's waiting. And then it will show the current movement speed. Then it will draw the server's local blue dot. And then this will erase the server's old blue dot copied. And again, this is copied from Lab 1. This is, again, copied from Lab 1 to keep it visible, because we did do a lot of this blue dot stuff. Then it sends that current information over the BLE, and then it will notify the connected client that new data is available. Read the gamepad, again, Lab 1, then the horizontal movement, vertical movement, then it will draw the dot there, and then the start button, which, again, low pressed, high not, and then it will activate when start changes from not pressed to pressed. Then this updates the speed displayed on the server. And then the select button, again, it will just warp to a random position for the entire dot. And then it tells the client to, again, warp that local blue dot also. Then you initialize the gamepad again. We talked about this. And then this will actually initialize the server, which also was done for us. So there were just a few things you needed to change here, but otherwise we had most of this done. Again, I kept crashing because I was notifying the client here, but the client, again, will still be discovering the service and registering those notifications. So the first packet will be sent after the joystick moment started select. That is why I kept crashing. It was taking way too long. And then this is the client. That was the server. This is the client. And then, again, we initiate our client variables. We have our screen and dot, again, calling our, again, these must match to connect them. Then we have our library. Notification to send like normal. Then it becomes a callback. Clear the status area, green text. Again, pretty much the same thing, except that this is actually happening on the client side, not the server. And so, again, same thing with the dot, it keeps the radius. Then, yeah, the client can actually call back, which, again, we want to change the variables here. And then this runs if the server is disconnected. Then it will do a scan callback and see if the device is discovered during the scan. And then it connects to that BLE server, which we learned in the lecture. And then after that, we'll start a BLE scan. Then it'll connect the server. And then through that is a main loop. It will update that. And then it will, if it detects a connection state change, then we want it to scan through. And then scan again when it's disconnected. And then for Lab 2 Part 2, which is Challenge 2, the only difference here was that there was going to be an opposing dot, and if they were fighting like on an online game, then it would do a game over. So the other one would just track the movement as what was happening on the other one. This one will be its own thing while connected to it, so they can fight against each other. And so this would, again, we want to define our UID, our position, and then, again, writes to the blue dot, variables, then here are BLE variables, screen and dot variables, counts if they're touching 8 pixels or close, that's why we use 18. Then this is the service with the blue dot, and then we want to change this from 1 to 5, then it goes back to 1, the speed always. Joystick variables. Again, a lot of this was just pretty much copy and paste. because we had it in the lecture, and in the following one, we're just changing it to a red dot. So let me get to the red dot part. Yeah, draw both dots. Here we go. So yeah, so then you redraw the whole game to avoid those black marks of the toxic close, which is the hot zone, and then you draw that game over when those dots hit, and then keep that local blue dot screen, and then check, which again took this code from Lab 1, which we talked about. Then it sends that server that the blue dot is positioned to the client, and then it processes that what the client wrote. So those are talking against each other on each side. And then after that, it reads the server's joysticks and moves it to the blue dot, reads and starts select on the server, so if it warps or if it changes its speed, and then it initializes that gamepad QT. Then it also initializes the server, writes the client to let the blue dot know the position back, so again it's talking to each other, and then you do the setup always, and then you loop it with the mtype update. And then once it's detected, it will start working. Always delay it, and then it will restart. And then if it hits a game over, then you have to just restart the device. But that pretty much wraps it up. Two pretty relatively simple labs, because the challenge one was just basically taking the first lab code with the Qt controller and all that working and putting it over a BLE client and just copying those actions happening with it, warping and incrementing. That's pretty much it. And then this one would be taking one side and connecting to another side and have them fight against each other. So if they hit, they get to game over. And that'll be it. And there will be 2 videos on the Google Drive for the view to see how that works. All right, thank you.